Right, I'm going to go over the R code, which didn't seem to work out well. I know why it didn't work out well, so I'll explain that well here now. The other day when I was trying to show you how to take the apple juice data, where we tasted 2 different brands of apple juice, and we wanted to know whether what we found was different than what the null distribution said. But in this case, we didn't have a null distribution, so we needed to simulate and get a null distribution. So the first thing you need to do is to, let's look at that data again as an Excel file first. So let's go here, let's go to here, data, it was this I hour apple juice. And what you see is these were your choices that you filled in. And 0.29% of you felt that brand 1 was better than brand 2. So that's what I did. I just did a count here in Excel, just the Excel tools. I'm actually going to get rid of this column. This was just for me to track. So let's just get rid of that and save that. Right, so about 29%. Let's keep that pinned in the head. All right, so I'm going to first load tidyverse. So that means I have to put my cursor by library tidyverse. I have to do that every time. That's what we get for using something free. Then I need to read in the data. I already set the session, but I need to set the choose the directory so that wherever my data lies. Remember, I won't see the data in here. I just need to set the folder so I'm using that particular folder. So I'm going to do that, and I see this set WD, teaching, so forth. All right, now I'm going to read in the data, which lies in that folder. So I have to put my cursor right behind where it says I hour, that line, and it's read in the data. If I go in here, I see that the data's been read. Just click this I hour, and I just double check that the data's been read. Right? Get rid of this. Too many things up here. All right, so now I'm going to count the number of observations and retain it. I know I can see that there's 16 there, but let me just do that. It just tells me about the data. It says there's 6 of us who preferred 1 over 10, so it gives me that breakdown. Choice 1, 2. It just records that proportion. So this command here, replications equals null, let's just see what that does. Right now it's empty. You see it's over here. That you need to do first, and that was something I wasn't doing in class. I kind of had driven on. I was discombobulated in class. I don't know what was going on. This num.reps equals 1,000. What that does is it tells me how many times I want to run the simulation. So I mentioned in class that if I gave every one of you a coin and asked you to flip it 10 times, that would give me some number of simulations. But if I wanted to run that same experiment 1,000 times in class manually, I would have to have you flip those coins again and again and again 1,000 times in 10 block replicates. I don't want to do that. I want to do that automatically. So this tells me how many times I want to run the simulation. 1,000 times. I can do that now. How many observations do I have? That's my sample size. 16. I can see that because over here where I read in I hour, it says 16 observations. The null probability, that's the parameter in my null hypothesis. If I was flipping a coin, if it was just random, then I would expect that the probability you chose 1 over 2 is a half. So that's what goes here, is what you expect if it was just random. So I put that in, null probability is a half. Now I run the simulations. So you see the statement for I equals 1 to number of reps, that just tells R to run that trial 1,000 times. And this command over here fills in as if we ran this in class one by one, each student taking a coin and flipping it. And I'm going to show you what happens as soon as I So if you see this little bracket here, I have to go to the other end of the bracket, down here. And what it's done, if you go over here, see, should have something that says replicates. There it is, 1,000 observations. That's my simulation. If I go click that, I'm not getting it. Right here, let's look at it. You're going to see this is student number 1's. There's 1,000 students running the simulation. They flipped a coin, and student number 1 got 0.4375% heads, and so forth. So this is the outcome as if someone just flipped a coin and I had 1,000 students doing it all at the same time. So you get a whole bunch of different proportions here simulated. That's what's going on here when I click this replication. So that's been made by that for statement that I had before. That this statement here, where the bracket ended, that's doing that simulation. So it's if I generated 1,000 students and they're all flipping coins, and it tells me what percentage of their 10 flips ended up being heads, let's say. Now, I'm going to plot that null distribution, but here I'm going to put 0.29, which is what we found to be the actual. That's the yellow that you guys, I'm sharing with you today in class, where I'm showing you what where my steps per day last. So I'm just going to see where our answers benchmarked against the null distribution. So if I do that, it tells me that this is what we got for choice number 1. If I had randomly chosen 1, I would have got this distribution with a peak right at 0.5. Well, I'm like the steps per day that I'm going to show you in class, very unlikely that this was due to random chance. It's over to the left. It's not even close to being somewhere in the middle. So I would say that's unlikely. So in this case, I would conclude from my eyeball test that it's unlikely this choice was random, and it looks like there was a preference for brand 2. So this is the p-value, and in this case, the p-value turns out to not look, actually I want it to be less than or equal, right? So less than or equal to 29, because what's the probability that this, so let's do that. And it says 0.033. In medicine, our cutoff for saying something statistically significant is 0.05. So I would say that my result here, because it's lower than 0.05, and understand this proportion, the proportion that I got out of everything being 0.29, being less than or equal to 0.29. So over in this region down here, it looks like it's unlikely because the p-value turned out to be less than 0.05. That's usually our cutoff. That's a rule of thumb. And so what that's saying is numerically, I can actually say with some level of assurance that we did not choose our brands, but just due to random chance. And so that's the summary of this R code, which I'm going to share with you.